A lot of times in chemistry, we have to make a solution from a stock or a very concentrated solution. So in order to make that our new solution, what we have to do is actually dilute that stock solution. So dilution, this is the procedure for preparing a less concentrated solution from a more concentrated one. Okay, and the equation that we use for dilution is that we take the molarity times the volume of our stock solution, and this is going to be equal to the molarity and the volume of our diluted solution, or M1V1 is equal to M2V2. All right, so let's see how this works. How would you prepare 200 milliliters of a 0.866 molar sodium hydroxide solution starting with a 5.07 molar stock solution? All right, so let's see what numbers and letters we know. So we know M1, the molarity of the stock solution, is 5.07 molar. Okay, the volume of that stock solution, you don't know. That one you do not know. Okay, so let's put a question mark there. Now, the molarity of your diluted solution, we know we're shooting for 0.866 molar. Okay, and the volume that we need for that second solution, that's going to be 200 milliliters. Okay, because the units all have to match up, we can't, and we've got molarity to be moles per liter. We need to convert this from the volume from moles per from milliliters to liters. So this is going to be 0.200 liters. All right, so that is very important for the dilution formula. The units all have to match each other. So it's got to be moles per liter and liters. Okay, so you can't mix and match. All right, so here's our equation. M1V1 is equal to M2V2. We're going to solve, because we know we're solving for V1, I'm going to divide both sides by M1. So that way we get V1 is equal to M2 times V2 divided by M1. All right, now all we have to do is just pop in our numbers. So V1 is going to be equal to M2, which is going to be 0.866 moles per liter, times V2, which is 0.200 liters. Okay, now notice what happens. Liters cancels out with liters already. How about that? All right, divided by the molarity. So that's going to be 5.07 mole per liter. Now, what's kind of nice is that moles, when we divide all this, moles and moles will cancel out, so you're going to be left with liters, and everything works out pretty good. So math-wise, this is going to be 0.866 times 0.2 divided by 5.01, and so the number I get when I calculate this is going to be 0.0342 liters. All right. Now, since our volume was originally reported with milliliters, we should pretty much match that. So that would be, once we do that conversion, that would be 34.2 milliliters. So how this would work is that you're going to take 34.2 milliliters from the stock solution, okay? So 34.2 milliliters is coming, of that 200 milliliters, is coming from the stock solution. So that means if we take 200 milliliters, because that's the volume that we're shooting for, 200 minus 34.2 milliliters, that tells us that the rest of this is gonna be water. That number comes out to be 165.8 milliliters of water.